Levels of code. Level 1. Binary. Binary code or absolute machine code are strings of ones and zeros. It is the lowest level of coding and it has a lot of problems. The main problem is that it is very easy to make a mistake, and once it is made, it is very hard to find it once you realize the mistake. Level 2. Assembly. Assembly language isn't much different from machine code, as it is just a symbolic representation of it, which allows symbolic designation of memory locations. No matter how close assembly is to machine code, the computer cannot understand it. The assembly language program should first be put through a separate program called an assembler. If the assembly language program needs to be changed, it is vital to change the code and reassemble it to create a new object program. Level 3. Compiler. Compiler languages are just high-level assembly languages. Each instruction in the compiler languages can mean many machine instructions. Once the code is written, it's changed to the machine code that is equivalent by a program called, you guessed it, compiler. Once the program is compiled, the machine code from it is saved separately and can be ran anytime. Like assembly language programs, changing the code requires that the source program be changed correctly and then recompiled. Usually, the compiled code is less efficient than the code from the assembly language. This means it runs slower and uses more memory, but it takes much less time to develop compiler than assembly. Level 4. Interpreter. An interpreter language is similar to compiler language. It is considered as high level, but it operates in a different way from compiler or assembly. The interpreter program resides in memory and executes the high-level program without preliminary translation to absolute machine code. The use of interpreter programs to execute the user's program has a good side and a downside. The main good side is that you can run the program to test it, make some changes, and run it again. There is no need to recompile because no more machine code is made. This can exponentially increase the speed of development and testing process. But on the downside, this requires that both the interpreter and the program reside in memory simultaneously. And since the interpreter has to scan only one line of the program at a time and runs inside parts of itself, and response execution of an interpretive program is slower than most languages. Hope you enjoyed the video.